So in this lesson, we're going to be converting fractions, decimals, and percentages. I can apply my knowledge of parts of total amounts so that I can express these parts as equivalent fractions, decimals, and percentages. I'll know I've got it when I score an 85% or better over the assignment following the lesson. So before we jump into doing our conversions between these fractions, decimal, and percent values, we are going to just take a peek at what fractions are and how they're related to decimals and to percentages. So first of all, fractions are definitely used in your lives and as well as in everyday life. So it's got an application here that you're going to need to understand just to function out there in that real world. Because not everything comes in whole amounts. And so when you think about fractions, where would you see them currently? You would see them when you're getting your grades from teachers. They're going to put your points over the total points that were possible on assignments as a fraction. And once they have that fraction determined, then they can convert that over to make your percentages for your assignments. So fractions are what are the foundation to form your grades in school. Another place where you would see it is if you're cooking. When you bake or cook, many times they give you the fraction of how many. You're not always using a whole cup or a whole 2 cups. Sometimes you need a cup and a half, 1.5 cups. Sometimes you need 3/4 of a cup. So in baking or cooking, you would use those fractions. So those are just 2 examples of where fractions come in. Measurement is like the umbrella for cooking, but even our measurement system with rulers and we do 1/8 of an inch, 1/16 of an inch. So that would be places where fractions would be used. So what is a fraction then? A fraction is a part of a whole. Okay, it's when we have a total amount, but we only have part of that total amount. We don't have, we're in between the 2 whole numbers. Okay, and it's important to understand that the denominator of fractions can be any number. For example, we might have the fraction 6/12. Okay, that's also the fraction 1/2. It's an equivalent fraction. We can have the fraction 18 over 290. When your teachers are making assignments up, their total points are here, and those total points are not always going to be the same for everything they do. It just depends on the assignment and how they're putting points together to make that assignment worth your grade, what you've earned. Okay, and the total amount is what they're hoping you get for mastery, showing mastery. Okay, so fractions are parts of wholes where your denominator can be any number we want it to be. Okay, decimals are also parts of whole amounts. A decimal is a part of a whole. We're in between our whole numbers. And the whole amount, the denominator, though, cannot just be any number. Our decimal system is built on the tenths, the hundredths, the thousands. So that's the first decimal place. To the right is tenths. So that's what I want up here. So tenths, hundredths, thousandths, and so on and so forth. So the next tenths. Oh, can't type. Tenths, hundredths, thousandths, and so forth. So our decimal, when we read decimal place values, these are the words we're going to put after our decimals. So if I give you this number right here, 0.12, a lot of times students will read it as 0.12, but really it's 12 hundredths. That last digit tells you how to read that place value so you can hear the denominator word. What is the total amount for this decimal? It would be 100. It'd be 12 hundredths. And then if we had 0.012, you would read that as 12 thousandths. So you can hear how much is in the whole by the last digit's place value. This would be 12 out of 1,000. This would be 12 out of 100. Think about money. 12, this is 12 cents. It's a dime and 2 pennies. It's 12 cents. It's 12 pennies out of 100 pennies to make that money. So it's part of a dollar. Okay. I didn't come up here to just kind of see where decimals come into place. When I work with you in decimals, a lot of times I just go to money because our money system is based on decimals out to the hundredths place. We have pennies, dimes, whole dollars, and so our money system goes out to the pennies place. We don't have a coin for thousandths. They could have invented a coin for thousands, but that would be crazy because it'd take 1,000 of those coins to make a whole dollar. And that'd be a lot of change to carry around just to change it out for $1. So they stopped with pennies, which is a lot also. 100 pennies make a dollar. But the money system measurement again, if you're in the US system, we measure to the eighths and quarters and sixteenths and halves. So those can be represented as decimals. The halves are 0.5, the quarters are 0.25, 0.5, and 0.75. And our eighths are 0.125, and then 0.25, and then 0.375, and then 0.5, then 0.625. So those are our eighths. So measurement comes in handy. And we also use the metric system. Those are tenths, hundredths, thousandths as well. So that's in measurement. The measurement system and the metric system is like our place value table with the tenths, hundredths, the thousandths. All right, so we've got money and measurement for decimals, and there's also other applications. And then finally, we're to the percentages. Again, your grades are based on percentages. Sales tax that you pay when you shop for things. If there's sales tax you have to pay in Indiana, it's 7%. Ooh. Sorry about that. Let's see if I can get that to move. 7% sales tax. We also, if you've ever been to Kohl's, you don't go there without your coupon because there's discounts, and they usually base a discount as a percent off the total bill of what it would originally pay. So those are just some examples of where you would see percentages. Again, a percent is part of a whole, just like fractions and decimals. Okay, and the whole amount, though, is very specific. The whole amount, your denominator of your percents, if we're talking that, it would be always out of 100. So when you're given a percent, they're describing the numerator compared to 100. And so when you got a percent for your grade, it's saying, hey, your percent is 30, let's go higher than that, 83%. You got 83% of the stuff correct compared to 100 possible. So that is percentages. So to kind of wrap up, our fraction has the broadest opportunity because we can use any denominator. Our decimals are limited to powers of 10 in the bottom of those fractions, tenths, hundredths, thousandths, and so on. And our percent is even more limited. It's always out of 100 when we're looking at how many pieces there are in the total. And you got to keep that in mind when we do this lesson. So now that we've reviewed the basic foundational knowledge of fractions, decimals, and percents, we're now just going to study some examples on how to convert fractions into decimals. So that's our first task. We're going to learn, so to convert any fraction into a decimal, you will divide the numerator by the denominator. So this is a division problem. When we read it, you can read it as 3/4, or you can read it as 3 divided by 4. The fraction bar is your division symbol. So if we want to convert this to a decimal, we simply do our long division. And I know let's quickly review. It's going to be a quick review if you struggle with the division, the long division process that we're going to work on here. You may need to go to a couple of videos and watch some more examples, but I'll quickly run through this because they didn't show you all the steps here. They just said set up your division problem, assuming you'd understand how to do it. So 4 is the denominator. The denominator is always your divisor. It reads 4 divided by 4, 3 divided by 4. Your 4 goes at the door. The 3 is what is being split into 4 equal sized pieces. So think of this as like you have $3 and you're splitting it with 4 people. You do not have enough to give everybody a whole dollar. Your answer is less than 1. So when you set up your division problem, if you set it up backwards, you're going to get an answer bigger than 1. Number sense is important here. The 3 goes in the house. The numerator always goes in the house. That never changes. So I say top dog goes in the house, denominator at the door. Okay, so 4 goes into 3 0 times. Every digit under the house will get a digit above it. So if it doesn't go in, you should put a 0 placeholder. So there's no ones place going on. This is in the ones place. The 0 goes up here. And then I just simply put a decimal on the end because I want it to be a decimal answer. I need to keep my long division going until it ends or repeats. So I'm going to stick the decimal here, stick it up on the house, and I'm going to add a 0 to my number. 4 goes into 30. It goes into 37 times. 4 times 7 is 28. And you subtract 30, take away 28. Well, that's just 2. I have a remainder, so I'm not done. I have to keep going till my value here ends or repeats itself. So now I add another 0, I bring it down, and I divide again. 4 goes into 20 5 times. Now I've got no remainder because 4 times 5 is 20. I simply subtract that and it works out. That's how they got the 0.75. I highly recommend putting that placeholder 0 in so you don't put the 7 here. If you put the 7 here, you're saying 4 goes into 3 7 times, and that is not correct. These are place value below, and the place values you put above match the place value they sit in below. It has to make sense. Okay, now this is a memorized one, so you should not need to do any computation for this. You should be able to just know that 3/4 is 75%, or 75 hundredths. Sorry, because we're going decimal, 75 hundredths. 3/4 is 75 cents. That's another way to have it. But this is the process when you don't know. When you don't know the decimal, you need to do this long division process. So converting fractions to decimals, you need to divide the numerator by the denominator. So here are 2 more examples of that division to convert this fraction 5/8 into a decimal. Again, this is one you're being asked to memorize. And this one actually has an error in it. I just noticed that. So you're going to need to fix your notes if they're not already fixed for you. So let's just walk through the long division process on this one. We're dividing 5 divided by 8, which is less than 1. If you have 5 people and $8, you can't give everybody a whole dollar. It's less than 1. So the 5 goes in the house, the 8 goes at the door, and I go 8 into 5 0 times, put the decimal here, put the decimal on the house here, and bring it up. Because we want to get the decimal form, we have to keep dividing. So I stick that decimal point in, put it on the house, and now I don't have to deal with it. Decimal's done. I'm going to add a 0, and I'm going to do 8 into 50. 8 goes into 56 times, and the answer is 48. And I'm going to subtract that. That becomes a 4. That becomes a 10. 10 take away 8 is 2, which you could have done without all that borrowing. 50 take away 48 is simply 2, right? But if you want to go through the process of that vertical math, you certainly can. Bring the 0 down. 8 goes into 22 times. I get 16. 8 times 2 is 16. I take that 16 off. And I get 4. Bring down the 0, add a 0, bring it down. Because I have a remainder, I just have to keep going and give my wonder, is this ever going to stop? Well, I'll usually tell you to round your answer or go till it ends or repeats. In this case, there was no rounding given, so we're going to go till it ends or repeats. And here it is. 8 times 5 is 40. We're going to minus that off, and now we have no remainder. So there is an error here on this note sheet. I don't know if I fixed it on yours or not, but if I didn't, it should be a 2.625. And again, you're asked to memorize the ACE as part of your lessons. Those are common ones that you should have memorized. But this is how you get it. If you don't know, you just do this long division. This one right here works out to be what we call a repeating decimal. When you do your long division, you're going to find that it ends up repeating. So let's work this one out so you can see how the repeater shows up in your long division. So I'm just going to erase the work for that. And we're going to set this one up. It's 3 2/9. So what I'm going to do here is I know my whole number is 3. I'm just going to keep that a 3, but I'm going to use the 2/9 to figure out the decimal part that's attached to that 3. So that's what I'm going to put under the house. It's 2 divided by 9. So the 2 goes in the house, the 9 goes at the door, and 9 goes into 2 0 times. So then I stick the decimal point in because I want to go decimal. I throw a 0 in there. That's still 2.0. I put the decimal in the house. Now I don't have to deal with it. I do it as 9 into 20. 9 goes into 22 times. And 9 times 2 is 18. And I subtract and I get a remainder of 2. So I throw a 0 on there to keep it going because I have a remainder. I have to go till I have no remainder. It ends. Or if the remainder repeats itself. 9 goes into 20. Oh, 2 times again. I'm going to get 18 again. Suddenly you notice you are repeating that process. It's going to continue like this the entire time because 9 will always go into 20 2 times. Once you notice that your remainder repeats itself, you're done. You put a repeating bar over the digit that repeats. Sometimes there's more than one digit. In this case, it's a 2 that's repeating. So my answer is going to be 0.2 repeating for this division. But it's not 0 because I had a mixed number. I had a 3. So this 0 is replaced by the 3 2/9, 3.2 repeating. Okay, in this problem, they want you to convert this fraction into a percentage. And when you see this fraction, remember fractions can have any denominators. This one is a 4. Percentages have to be out of 100. So it's very easy to convert this one because we know 4 goes into 100. So we can just create an equivalent fraction by scaling up the denominator to 100. To scale it up, it means we need to multiply 4 times 25. And to keep the fraction equivalent, whatever you multiply to the bottom, you also have to multiply to the top. So we go 3 times 25 is 75. Once that fraction is out of 100, you know the percent is that numerator. So that's a pretty easy job to do when your denominator goes into 100 evenly. In this example, we have for converting a percent over to, to convert the fraction to a percent. This one was very easy. It's already out of 100. So we just write it as 22% because remember, percents are out of 100, okay? This one right here, though, however, is 50. So just scale it up, double it. Whatever you do to the bottom, you have to match on the top, double 11, and you get your 22%. So there you have it. For that one, it's very easy. This one, not so much, because 8 does not go into 100 evenly. It will go into 100. It just goes 12.5 times. So we could have, if you know that 8 times 12.5 is 100 off the top of your head, then that's a very efficient way to convert this problem, because you would just scale it up by 12.5. A lot of us don't know that off the top of our head. We'd have to do a little division to figure that out. We'd have to divide 100 by 8, and that's a bit of work. And then we'd have to multiply 7 times 12.5, which would come out 87.5. So it's a bit of work to try to do this same strategy here. It's not very efficient. So part of this lesson is learning how to do things efficiently. So 7/8 is one you're supposed to have memorized as the decimal and the percent. And so if you have it memorized, you just convert it to the decimal. And once it's in decimal form, you're going to convert it to a percent by multiplying that decimal by 100, which simply moves the decimal 2 places to the right, like so. So you can mental math that multiplication without having to do any work. Now, again, if you don't know the decimal for 7/8, your backup plan is to do that long division. 7 in the house, 8 at the door. and start your division with 0, tack your 0 on and keep going. I've gone through 2 examples already on how to divide and convert to decimal. So I'm not going to run through this problem, but when you do your long division, you'll end up with 3 zeros to the right, and you'll have no remainder. And by the time you get to this digit and you've divided 8 into whatever that number is 5 times, you'll have no remainder, and you'll be done with that long division process. And then once you have that, you'll take that answer right here, multiply it by 100, which simply swoops your decimal 2 places to the right, and you've got your percent. So equivalent fractions, when you know quickly what to multiply that denominator you got to get it to 100 to scale it up, because percent means out of 100, or convert your fraction into a decimal by long division. And once you have the decimal form, multiply that decimal by 100 to get your percent. Okay, now we're going to try converting decimal into a fraction. We're going to start with a decimal and make it a fraction. Well, this is one of the easier pieces to do in this lesson. The problem I find is students, it's so easy you forget how to do it. So when you're looking at this right here, this number, I'll say, hey, read that number to me. And a lot of kids will say it's 0.25. Okay, that's not going to help you with this if you don't use place value words. So you need to read this number and use place value words. So this says decimal fraction. Use a place value bigger than the numerator for the denominator and then reduce and simplify. Okay, here's what I tell you to do. You're going to read it. 25 hundredths. 25 hundredths. When you read that fraction or that decimal, you hear the fraction for it. So after you've read it, write the fraction you just read. 25 over 100, 25 hundredths. And now you have to reduce or simplify it. This can be divided by 25 in the top and 25 in the bottom, because we want it in lowest terms. If you didn't see 25, you might have said 5 goes into it, and you would end up with 5 over 20, and then 5 goes into 5 and 20, you'd reduce again. But lowest terms would be 1/4, and that's the goal. You have to recognize whether or not your fraction is reduced once you get it from the decimal to the fraction, and then lowest terms. So look for that last step. Don't leave it unsimplified. Okay, this next one, we have a practice on this. Here's our decimal. Here's the read, 27, that's your numerator, hundredths, because this is in the hundredths place. That's where they got that denominator from. Powers of 10. Remember, decimals are always powers of 10. And once you have that, you just make sure it's in lowest terms. Well, the factors of 27 are 1, 3, 9, and 27. The factors of 100 are 1, 2, 4, oh boy, let's see, 6, 8, 10, 5, 20, 25. There's a bunch, but the only factor that these two numbers have in common is a 1. Therefore, this is in lowest terms. Nothing else I can do. I'm done. This one right here, 321. The 1 is in the thousands place, so that tells you what to put in your denominator, 321 thousandths. Now this is a little tricky because you have to know if this is in lowest terms. And so that's a big fraction to figure out. What some tricks of the trade are, well, if they were both even, you could start dividing 2 out because they would have a common factor of 2. Sometimes the numbers are big and you have to just start breaking that number down with numbers that you know go into both. And in this case, this is in lowest terms. The only number that goes into both of these is the number 1. Okay, here we're going to start with the decimal and we're going to convert it to a percentage. To go from a decimal to percent, it's a simple multiplication problem. So if you have 0.25, 25 hundredths, okay, first of all, you can kind of see it like this. If you might think of the fraction version, 25 hundredths, and that's out of 100 already. So that you could just do it like that. But the other method is to every time you have a decimal and you want to change it to a percent, you simply multiply that decimal times 100. So there's the math problem you would use. Here's the mental math we do. You should know that anytime you multiply by 100, it's 10 times 10, right? It's 2 factors of 10. Each 10 moves that decimal point 1 place. So 100 would move your decimal point 2 places because there's 2 factors of 10 in it. So your answer would be 25%. And that's how you would show the work for that right here. It would be, hey, I'm going to move it 2 places because I'm going to multiply it by 100 and it's going to land on 25%. So you'd swoop, swoop, and then clean it up so we can see what you ended with. And since we're converting it to a percent, you must have that percent sign on your answer. Okay, so the 3 times 100, when you read this, it's 3. So we're not going to be able just to go boop, boop, because we don't have that hundreds place mark. So it's just the whole number 3. And we multiply it by 100, it's simply swooping the decimal. And kids will go, oh, there is no decimal, Miss Vanberg. No, because it's in simplest form. Whole numbers, we don't go like this. We don't stick a decimal on a whole number. We drop it to make it in its simplest form. So when we need to move a decimal on a whole number, we stick it to the right of the ones place. The 3 is in the ones place. And then we go swoop, swoop, 2 places to the right, and we fill our holes with zeros, and 3 is 300%. We stick that percent sign on. And finally, this 1.234. Again, when we read this, it's 1 in 234 thousandths. That's not out of 100 right here when we read it. So it's not real helpful to just try to get it there. The simplest way is to just simply multiply that mixed number by 100. And when I do that, it moves my decimal point 2 places to the right. And it's 123.4%. So these 2 examples, you can clearly see it was what we just did above. It's a swoop, swoop. That's how you would show your work to tell me you're doing some multiplying by 100. And you would get your percent, and you tack that percent sign on when you're done. This one right here, double swoop, and percent sign on it when you're done. All right, we're going from a percent to a fraction on this one. Again, pretty easy to do because the definition of percent is out of 100, per 100. So it says take your percentage, the 24, and place it over 100. And now you have your fraction. However, you need to make sure you reduce or put it in lowest terms. So you need to figure out the common GCF of 24 and 10. Some people will go, well, 2 goes in, and you can do that. And if you break it down with 2 first, you get 12 out of 50. You are not done. 2 goes into both of those, and you get 6 out of 25. So make sure when you're reducing, you get it all the way to the bottom. Hopefully you see that the GCF is 4. If we divide by 2 here to get 12 and divide by 2 again, we've divided by 4. So a factor of 4 altogether. So 24 divided by 4 is 6, and 100 divided by 4 is 25. So here are some more examples. Just take your percentage and put it over 100 because 45% means 45 per 100. And then reduce it. 5, I know 5 goes into both. Is that the greatest one? I'm not sure. Well, I am sure, but you might not be sure. But start with that. It's real obvious that 5 goes into both because they both end in a 5 and a 0. And 5 goes into all numbers that end in 5 and 0. So 45 divided by 5 is 9, and 100 divided by 5 is 20. There you go. Now you have it in its lowest terms because the only factors that go into 9 and 20 are 1. So that means you're done in that lowest term simplifying. Okay, this one right here, 213%. You just write the percent over 100. It is an improper fraction. It's top heavy. The numerator is bigger than the denominator, so you are going to end up with a number larger than 1. Here, we got a proper fraction. Our answer was smaller than 1. Here, fraction smaller than 1. Here, it's an improper fraction. Our answer is bigger than 1. So you convert this back to a mixed number, 2 and 13/10. Remember to convert back to a mixed number. You can do some mental math in your head, but you're ultimately dividing 213 by 100. And it goes 2 times, that's 200. And you have a remainder. The remainder is 13, 13 over 100. So you have to remember how to convert those impropers back using long division. Sometimes that division can be done mentally. Sometimes you need to work it out. Just depends on your skill level. Okay, this is our final set. We have percents to decimals. If you're given a percent, you simply are going to divide your percent by 100, because remember, 25% is 25 over 100. That means 25 divided by 100. So it would look like this with long division. 25 in the house, 100 at the door. Here's the beauty of it. We don't have to do long division. When we divide by 100, you need to recall your skills. When you divide by powers of 10, it's just moving the decimal, but this time move it to the left. And it's 2 places, again, because every time you have a 10 in your denominator, and 100 is 10 times 10, we have 2 factors of 10 in 100, we move it 1 place for each factor. So if it's 25, which 25% is 25, the decimal goes after the ones place, and we swoop it 2 to the left to complete this division. And then it ends up 0.25. That's the decimal. So the 342 divided by 100. It's this, right? There's the fraction, but ooh, that's terrible. But that means 342 divided by 100. So we take 342, the decimal starts here, we swoop it 2 in, and we end up with 3.42 for the decimal of that. And finally, 2.31% divided by 100. That's what we're going to do, but we only have to do the swooping. That's how you divide, the shortcut method, so you don't have to do long division. And it goes to the left. Fill your holes with zeros. So it's 0.0231. So that's just a decimal move. 2 to the left when we're going from percent form into decimal form. So they're just showing you here how to go from a percent to a decimal, because you are dividing by 100. It's 2 swoops to the left. 8% as a decimal, it's 8 divided by 100, which is 2 swoops to the left. And that converts it. It's just a decimal move. Okay, I would like you to try to do these 3 problems. You're going to pause the video. You're going to go back to the examples on the first page and second page in the notes to assist you if you're not sure how to do it straight up. You need to show work. So the work that was modeled in those examples is the work I should be seeing. If it's decide what strategy you're going to use, and then show that strategy on your notes, and turn the video back on to see how you did on these 3 problems. Okay, in the first problem, they wanted 88% as a fraction. Remember, percent means out of 100, so you should have just simply written 88 out of 100. And then you needed to reduce this. 4 is the GCF of 88 and 100. So I just went right to 4 and I divided 4 out of the top and the bottom. If you didn't see 4 and you used 2, you would have gotten, for 2, you would have gotten 44 out of 50. And then you would notice you'd have to use 2 again, and that would be 22 out of 25. So if you took 2 steps to break it down, totally fine. If you use the GCF, it's a little faster. So that's how you would do the first one. Second one, you should have gotten 60%. 2 options on this one. You didn't have to show both options. Which way did you go? Did you create an equivalent fraction because 5 goes into 100 evenly and percent is out of 100? So we just scaled the 5 up to 100 using 20. And whatever you do to the bottom, you do to the top. So we scaled 3 up to 60. And then 60 over 100 clearly is 60%. The numerator is your percentage. If you didn't see that, did you use your long division and show your long division? It would be 5 into 3. And then you would work that out. 5 goes into 3 0 times. 5 goes into 36 times. 30 minus 30 is 0. You're done because you have no remainder. So you have this decimal. Now you got to move that, you got to multiply that by 100 to convert the decimal to this percent, which is a 2 swoop situation. Fill your holes with 0, swoop to the right, and it's 60%. Either one of these. And finally, 8% or 8 hundredths as a percentage. 8 hundredths, you could have done this. You could have said, I didn't put this one down, but if you read it as 8 hundredths, you could have just written this, transform it to a fraction because it's already hundredths, and that's your percent. Or you could have gone the route where you move the decimal 2 places to the right because you're multiplying by 100. So if there's any steps you left out on this problem, you need to get them in because this is the work that's going to support you know what you're doing. So I can see the process you're using and assist you if needed. It's either this or this. If you left anything out, get it down on your notes so you can have some solid examples of the steps that happen to get from your fraction to your percent. And finally, you're either doing this method or this method. Make sure you have that information down on your notes, one or the other. If you want both, feel free. Okay, here's another set of problems. I want you to go back to the notes if you need to, the examples on the previous pages. You're going to be converting 51% to a decimal, 20% to a fraction, and 7/40ths to a percentage. Pause the video, make sure you show your detailed steps as they were modeled in the examples. If you're using long division on any, you're actually working the long division out yourself and showing you know that process. All right, pause the video and get to work. Turn it back on to see if you got them right. Okay, the first problem was the first thing you needed to have down if you were converting the percent to a decimal is that it's a division problem by 100. Because 51% is 51 over 100, which is division. And when we divide by 100, we show our swoop 2 to the left, and then we write our final answer nice and clear after we do our swooping. So this would be the work you'd have to show. If I was asking you to show work, this would be it. Okay, and then this next one, 20%, even though this can be done mental math. I know you can do this probably in your head, but I want to see what's happening. What are you doing? So, and you need to acknowledge what you're doing. You're dividing by 100. That's key. And once we get enough under our belt, then we can start losing some of these steps. 20% as a fraction, well, that's 20 over 100. So the first step is to show me you recognize that percent symbol means per 100. So you write that down. And then we get it into its lowest terms if it's not already there. And 20 goes into both 100 and 20. If you didn't see that, you might have divided by 10 and gotten 2 over 10. And then 2 goes into both and gotten your 1/5 that way. Some people might have divided by 5 first, and if you divide 20 by 5, you get 4. If you divide 100 by 5, you get 20, and now you got to divide the 4 out of that, which is 1/5. Some of you may have divided by 4 first. If you did that, you get 5 over 25, which is also 1/5. How you reduce it just depends on your skill level, and if you know what the greatest common factor is. That's the most efficient way because 20 is the GCF of 20 and 100. So that's only a one step to get it into lowest terms. If you pick other factors that are not the greatest common factor, it's going to take you longer to break it down, but you just have to keep going till you're done. 7/40ths is our fraction. And I happen to know that 40 times 2.5 is 100. So my way of doing this was pretty efficient because I had that mental math in my head. So if you knew that, you could have just created this equivalent fraction where you multiplied 40 times 2.5 and 7 times 2.5. And if that's mental math for you, great. If it's not, it really isn't a very efficient way to do it because you'd have to divide 100 by 40 to get this number. And when you divide 100 by 40, you get 2.5. And then you'd have to know in mental math, if you're not good at 2.5 times 7 in your head, then you got to set that up, so there's some division that you'd have to do and multiplication. So for those of you that didn't have this strategy, totally fine. Your strategy then should have been the long division process. And there it is. That's how it works out. And we get 0.175. And then when we're done, that's the decimal form. We got to multiply it by 100 to get it into its percent form, which is a swoop 2 to the right, 17.5. So there's more work needed here. You had the whole box to show this. I got kind of cramped because I did 2 different strategies, one or the other. So whichever one you had, check that you have it right and that you have all the steps on your screen there for showing me how you did it. All right. and then go on to the next set of problems. So you're converting 7/10 to a percent, 3/25 to a decimal, and 43% to a decimal. Show your steps as we've been doing all along so we can see your thinking and you can check to make sure you have the steps figured out correctly. Pause the video, turn it back on when you're done. Okay, in the first example, most students would probably do my second strategy. They just take 0.7 and times it by 100 to convert the decimal to a percent, which is a 2 swoop to the right when we multiply by 100 and you get 70%. But some students might say, well, that's 7/10. So if I have that fraction 7/10 and I scale it up out of 100, I could get 70 out of 100, which is also the percent. Both of these are very efficient methods for this easier decimal. But if you don't know how to scale up whatever this number might be, let's say it was 0.125, and you put that's 125 over 1,000, then you're going to have to scale it down. So it might not be the most efficient way. Just multiply it by 100, swoop it twice. Okay, this one right here, 3/25 as a decimal. Some students might have said, well, I know I can get a power of 10 in the bottom from a 25. I can scale it up to 100 pretty easily. So you just scaled it to get it out of 100, and that's 12 hundredths. And once you have that, you write the number 12 and the 2 is in the hundredths place. Okay. If you didn't know that strategy, it's a quick method. If you recognize that you can scale up to powers of 10, like 10, 100, 1,000 with the numbers you're given, go for it. Otherwise, you are doing long division. 3 divided by 25. So 3 divided by 25, it comes out to be 0.12 when you do the long division. If you're slow on that long division, not sure what to do, look at those steps and make sure your steps match or get them down correctly. And then you have your decimal because we got ended with 0, no remainder. We're done at the hundredths place here, and it's 0.12. Finally, 43 divided by 100, swoop 2 to the left because we're dividing by 100, and there's your decimal from a percentage. So again, make sure you have one of these down and all the steps included, funneled neatly. One of these methods down and make sure you have the steps included so that I know what you're doing. And then finally, the last example, there was only one option there. So make sure you have the steps down, the 3 rows. We're going to use mental math on these. These are commonly mixed up decimal to percentages and percentages to decimals conversion. We're going to start with the top row, which is percent to a decimal. So a lot of times kids will see 500% and they'll say they'll convert that to a decimal and they won't use the knowledge of division. They just start moving the decimal wherever they think it should go. So make sure when you're doing 500, you're dividing it by 100. Right? That means a 2 swoop to the left. So it's 1, 2. And the answer is 5 as a decimal. 500% is the whole number 5. And then 50% divided by 100, that's 2 swoops. Usually students are pretty good with this. 50% swoop, that's usually not an issue. 0.5. is your decimal. A lot of times you might call that 0.5 just because you're used to percentages being less than a whole, but they don't have to be. Okay, and then 5%, a lot of students will write it as 0.5 again, but you're not. You're dividing 5 by 100. And it's like having $5 and 100 people. How much money is everybody going to get? A lot less than $1 because you have $5 and 100 people. So we're going to swoop 2 to the left. And we're at 0.05, which is 5 cents. Okay, this is 50 cents. That's 5 cents. All right, and finally, if we have 0.5%, that's this fraction, 0.5%. That's not much. That's half a percent. So what we're going to do is we're going to go 0.5 divided by 100. We still have to swoop 2 to the left. Doesn't change. So we go 0.5. And we swoop 2 to the left, 1, 2, and we got to fill the holes with zeros. It's 5 thousandths. Less than a penny. Okay, 0.5%, it's half a penny. Okay, Now we're going to reverse it. We have the whole number, 4, and we're going to convert that decimal. Remember, 4 is still a decimal. It's just in its simplest form. We can stick that on. It looks weird. We don't usually do that, but we will in this case because we're going to multiply 4 times 100 to convert it up to that percentage. So it's 4, swoop, swoop, fill your holes with zeros. That's 400%. And then 0.4 as a percent, times it by 100. That's swoop, swoop again. Fill your hole. That's 40%. And then 0.04, 4 cents. What percent of a dollar is 4 cents, right? Multiply it by 100 if you don't know. Swoop, swoop, 2 to the right. It's 4%, 4 cents, 4%. And then 0.04004 times 100, we're going to swoop it twice. And it doesn't clear the 4. It's in front of it. 0.4%. So you have to stick with the rule. When we're multiplying and dividing by 100, it's 2 swoops to the right when we multiply, the number gets bigger. 2 swoops to the left when we divide, the number should get smaller. All right, we've got one more piece to do. Okay, so we're going to compare these positive rational numbers, 40% and 45 hundredths. I'm going to convert this to a decimal by dividing it by 100, which means I'm swooping that decimal 2 places to the left to get that conversion to happen, and I get 0.40. And it's very easy to see now that 40 cents, ultimately like money, 40 cents is smaller than 45 cents. So that's one way you could do it. You could have multiplied this one by 100 to convert it up to that percentage, and you could have had 45%. And then it's easy to see that 40% is smaller than 45%. So making these into the same format makes it very easy to compare and avoids those careless errors that sometimes our brains make. So 3%, if I divide that by 100, I can get it into the decimal form because that's what this one's in. So I'm going to try to get them to match. The decimal point would be right here to the right of the 3, swoop 2 in to divide by 100, and I get 0.03, which shows that these decimals and this percent, 3% is equivalent to 3 hundredths. Think about the money, 3% of a dollar is 3 pennies, and that's that decimal for it. Or I could have multiplied that by 100 and built it up to become the percent, and it would have been a swoop 2 to the right this time, and we would have gotten this as 3% to see they are equal. 1/4, that's one of our memorized percentages. So hopefully you know that is 25%. That would be the easiest way to do this one. And if you didn't know that that was 25%, you can make it out of 100 by creating that equivalent fraction to convert it to that percentage. And it would be 25 out of 100, 25%. And 25% is smaller than 26%. All right, so that would probably be your most efficient way is to convert this to a percent rather than converting that to a fraction. That becomes a little bit more work. So that does conclude the notes for this lesson. So good luck with your assignment.